Welcome to Edureka. This is Anuj. So today what we will do is having a look at what multi-chain is, how it is different from the blockchain stacks that we have learned. Then we will switch our focus on some of the already running blockchain projects or already working blockchain projects, and what are the key areas or sectors in which blockchain is being used, how is the market growing, expect in the years to come. So what is multi-chain? So multi-chain is nothing but a fork of Bitcoin, which was done in year 2013 and 14. When the Ethereum project was coming up, the developers in the Bitcoin community think that, why can't we create a fork from the Bitcoin and make it as a permissioned or a private blockchain, which has similar features to that of a Bitcoin, can be implemented in a private network. So that's the core concept of multi-chain, that it is pretty much similar to what Bitcoin is. And only thing which is different from Bitcoin is that you can create your own private or permissioned network out of. So that is the major difference. However, one of the major limitation of multi-chain is that it does not allow you to write the smart contract. Although you can transfer the assets, you can define assets, you can transfer the asset, but you cannot write the smart contract or you cannot implement any kind of a logic in it. So the applications of multi-chain are very, very limited. One of the key application of multi-chain network is that, if you want to use it for, say, college project or research projects, or if you want to quickly demonstrate, the blockchain, generally, if you set up the Ethereum network, it would take you around half an hour or 1 hour with the help of emulator. If you set up the Hyperledger Fabric, it will take you maybe 3-4 hours to set up. Multi-chain, it takes hardly 1 or 2 minutes to set up the entire network. It's that easy. It's plain a couple of commands you need to give, and your multi-chain setup is ready for deployment. So let's see some of the key features and what are the differences between multi-chain and the blockchain technologies that we have learned so far. So these are some of the differences and similarities of multi-chain from other blockchain network. So the first feature of multi-chain is that it is very, very lightweight private network. So when I say very, very lightweight, means in terms of size also, in terms of CPU also, and in terms of your deployment time also. It is comparatively very, very light. It is a fork from Bitcoin Core, started in year 2014. It does not have smart contracts. It does not have any cryptocurrencies or native assets. So cryptocurrency of Bitcoin, so that has been eliminated in this fork. So there is no default cryptocurrency here. You can define your assets and transfer it, but there are no native assets which are built in this implementation. And it does not even have the proof of work as a consensus algorithm. Miner is designated by the admin, or the person who is creating the multi-chain network designates the miner who is going to mine the block. So miner is selected by the administrator or the person who is creating the multi-chain network, and is not done any work of stake. It's very, very simple, and it's very, very fast also. So there are three concepts here. One is asset. You can create a asset. So for example, if you create, say, example dollar, and you give it a value 1000, then you can transfer a part of that asset to other stakeholders, and you can assign the rights for that asset to be used by other stakeholders. Similarly, the second thing that you have here is streams. Streams are basically the simple databases. So you can store some key value information in a stream, and then you can pass those data values to other nodes in the network. So that's how simple multi-chain is. One of the limitation of multi-chain is that it does not work on Docker container model. It does not have any kind of an emulator also. So multi-chain, you will need to create the actual network in order to use it. So that is another limitation. So you will need multiple machines, and you will need to designate them as nodes in order to use the multi-chain network. So it is blockchain for enterprise because it is permissioned in nature, and these are some of the key characteristics, like it has got designated miners. So if you are creating a multi-chain network, you can designate who will be mining the blocks. By default, the admin of the network or the person who is creating the multi-chain network will be mining the blocks by default, but you can delegate that responsibility to any other node. There is a collective admin. You can make anyone admin. You can give the rights to any other node. So for example, if you are a multi-chain network creator and you create some kind of an asset, you can give the right of owning that asset to any other node along with you, or maybe you transfer the ownership of your stream or database that you have created and transfer the ownership of that particular stream to any other node. So it's a collective administration of the assets that are there in multi-chain. It uses blockchain as a tool and not as an ideology. So there are a lot of concepts that blockchain has to have, like consensus, which is not essentially followed in multi-chain. So it is using blockchain as a tool and not necessary as a ideology, and it does not have any kind of a cryptocurrency as well. But essentially, it is using all the features that Bitcoin uses, except for the features that it uses for cryptocurrency, like it will not have UTXO, it will not have the database. But all other features, like how you transfer the message, how public key private keys are used, how the wallets are created, all those things are similar to Bitcoin. It has got a private shared database, which we call it as stream. Okay, it has got no cryptocurrency, so Bitcoin, etc., nothing is there, and the details are hidden, as you have in any other blockchain network. So multi-chain is an off-the-shelf platform for creating and deployment of private blockchains, either within or between organizations. So as long as your systems are connected with each other, you can designate them as multi-chain nodes, even within your organization or outside your organization. The only thing that you need to ensure is the connectivity. So as long as they are able to ping each other, they can become the nodes. Derived from Bitcoin software core, hence it is compatible with Bitcoin ecosystem. So that's the advantage, that it is coming from Bitcoin. It is a fork from Bitcoin, so it is backward compatible with the Bitcoin ecosystem. Another good point is that it supports Windows, Linux, and Mac. So you can install multi-chain either in Windows, Linux, or Mac, and you can make them as peers to each other. So that is another good feature. Provides a simple API and command line interface that makes it easy to maintain and deploy. So basically, understanding and learning the commands that multi-chain uses is very, very simple. I think if you want to learn end-to-end multi-chain, it's a matter of 3-4 days or maximum a week to learn this entire multi-chain, all the commands, everything which is available here. While if you try to do the same thing with Ethereum, it will take you around 3 to 4 months, and with Hyperledger Fabric, it might take 6 to 7 months or maybe more. Rapid deployments, it is very easy to deploy. Managed permissions, you as a creator of a multi-chain network can always assign permissions to the peers. Those permissions can be like who can connect with the chain, who can send and receive the transaction, who can create the asset, streams, and blocks. And blocks means who can actually mine the block. And each blockchain is open or closed as you need. There is unlimited amount of asset that you can create. So there is no restriction on what category and how much asset you want to create. As an admin, you can create any amount of asset, and then you can distribute it to any granular detail. So it basically supports multi-party atomic exchange transaction. If you have $1,000, so you can even give $0.0001 to any other party if you want. Data stream, as I mentioned, are simple database which have the key value combination. So as a multi-chain administrator, you can create these data streams and you can share them with the peers by using the simple commands. So it started as a fork, and that fork was called as CoinSpark in year 2014. And now we are at version 3 of MultiChain. MultiChain website, if you will see, you can simply download MultiChain and install it from here. Otherwise, the entire set of commands, etc., is given here. How to create or connect to the blockchain. You will find all set of commands which are available. So, download. These are the 3 versions. I think there is a commercial version which is also available, which is paid now. And these are the commands that you need to basically learn. How do you create a blockchain? How do you start the daemon? How do you connect to the blockchain which is already running? How do you get into a CLI mode, interactive mode? And then what all commands you can run. So we will go through all these commands. We can create streams, we can create assets, we can subscribe and pass those assets to other nodes as well. So Bitcoin to private blockchain. So it is a fork of Bitcoin. So many aspects of multi-chain design are aimed at enabling smooth transition between private blockchains and Bitcoin blockchains in either direction. It's a multi-currency and messaging feature work very similar to the CoinSpark protocol for enhancing Bitcoin transaction. It can act as a node of a regular Bitcoin. And so because it is backward compatible, it is a soft fork, so it is compatible with the Bitcoin core network. It uses Bitcoin protocol, transaction, and blockchain architecture, which change only to handshaking process. Handshaking process in Bitcoin is through wallet, and by using the public private key here, you need to assign those permissions before you can connect. So it's not a public network, it is a private permission network where for joining the network you need the permission. Its interface is fully compatible with that of Bitcoin Core with all additional functionality provided by new commands. So you can basically see the transactions on a Bitcoin wallet also, that you know how it is actually functioning. The main aim of multi-chain is to ensure that visibility of blockchain's activity must be chosen through the chosen participants to control over which transactions are permitted to enable more secure mining with proof of work and its associated costs. So mining is not done through proof of work here. It is chosen miner who creates the block. The blockchain systems only store transactions related to the participants. Now this is the handshaking process. Like each node will create the chain or a new chain, and then whosoever wants to connect with it will need to give the connection string before they can connect to that particular chain. Each node presents its identity as public address on a permissioned list. Each node verifies the other's address on its own permitted list. So I think these will be more clear, when we do it practically. Each node sends a challenging message to other party, and each node sends back the signature of the challenge message, providing their ownership of the private key corresponding to the public address. And if the keys do match, then they are basically connected with each other. Again, these are the use cases, like, it is very lightweight. So these can be the possible implementations, like, crowdfunding, gift cards, loyalty points, where your assets are not driven by any particular rules. You can just transfer the asset from one place to another. The similar thing that happens in loyalty points. So in those very, very simple scenarios, you can use multi-chain. Otherwise, for any kind of a asset, which has some business rules, you cannot implement it in multi-chain. Provenance tracking is a standard feature of blockchain, where you can basically track the asset from beginning till the end. So that is also part of multi-chain. You have the blocks, you have the transactions, you can trace any transaction backward. So that feature is there. Inter-organization record keeping. So as I mentioned, that it can work on multiple organizations as long as they are able to connect with each other, and each organization will be keeping the records. It does not have any concept of a private data set or a public data set. So everything, if you're connected, then you will have the same copy of databases across all the nodes, just like in your Bitcoin. So since it is permissioned in nature, in order to connect to the network, you need permission. In order to send or receive transaction, you need permission. In order to write to the stream, means if you want to create a database and if you want to use that database, you need permission. If you want to create an asset or if you want to issue the asset to someone, you need the permission. If you want to add blocks, means if you want to act as a miner, then also you need the permission, and change permissions by consensus. So for performing every activity, you need permissions in multi-chain network, and those permissions are given by the administrator who has created this chain. Either he can give the permissions or he can delegate the admin role to anyone else who can provide the permission. There is no need of smart contract, flexible asset metadata, permission follow, atomic multi-asset payments, atomic asset exchanges, multi-signature for security escrow, and subscribe to the asset every transaction. So we will see all these transfer of assets from one node to another in our practical demonstration. Our streams are just like your small databases. It's not a traditional database. It's just like a key pair value, and using the key, you can retrieve the value, just like you have in your level DB kind of a thing. In order to transfer stream from one node to another, you need to give the permission, and in order to use the stream at other node also, you need the permission. So what is the stream? It provides a natural abstraction for blockchain use case which focus on general data retrieval, timestamping, and archiving. Any number of streams can be used, and each stream can act as independent append-only collection of items. Nodes choose which stream to index, and streams can be used to implement 3 different types of databases. So essentially what we use is this, a key value database or a document store in a style of NoSQL. What we can also create is a time series database which focus on ordering of entity, and identity driven database where entities are classified according to their author. Now the consensus model is based on the designated miner. If you choose a miner, he will create the blocks, and if there are multiple miners, then the miner is selected on the round robin manner. So if you have been given a chance to mine a block, then somebody else will be mining the block in the next iteration. There is no mining reward as we have in Bitcoin. because there is no cryptocurrency here. There is no native asset here. So mining is generally a duty that everyone needs to do, and by doing the mining, he is not running any kind of an algorithm. He is just collecting the transactions, validating the transactions, putting them into the block, and transferring the block or transmitting the block to the network. And each block digitally signed by the creator, only permission parties can mine. So before designating a miner, you need to provide the permission to the mining. The mining, as I already mentioned, it uses a randomized round robin system of block adders and a concept of mining diversity. So as an admin, if I assign 4 nodes as miner, so each node will get a chance to mine the block one by one. And once all 4 are done, then again it will go to the first miner. So it's a kind of a round robin system, and nobody gets any incentive for doing the mining. MultiChain flexibility, okay, it has got various parameters that you can configure. Like for example, block size, time, what kind of permissioning you want to give, what kind of consensus algorithm, mining, etc. All these parameters can be configured. So there are 45 plus parameters that you can configure. The permissions can change over time. As an admin, you can always change the permissions whenever you want. You can always create new assets. You can reissue and you can even destroy those assets, as an admin. And you can create and share the streams or data that you create. You can custom the metadata everywhere, and you have unified JSON RPC API for applications. So there is a interface which is given for UI application, and that interface is your JSON RPC API implementation. Again, you can find the details of that in this documentation. So deployment options for MultiChain are very simple and straightforward. You can deploy it in a singular data center. You can deploy it in a cloud-based environment. You can deploy even in a multi-cloud environment. As long as your nodes are pingable to each other, you can ping one node from another node. You can make them multi-chain nodes, irrespective of the OS, irrespective of the location, and irrespective where they are in the system. API cleanly separates app from node, shared administration tool, smooth governance transitions. It is a fork from Bitcoin Core, so it has got a lot of experience. The reason it was created was because it was initially thought that, based on the success of Bitcoin, MultiChain will also achieve similar kind of a success in a private or a permissioned network. But then this lack of smart contracting ability in MultiChain has actually hampered the basic purpose of this, and therefore it is not used effectively in any domain. Full multi-signature support, so it has again the public private key, same as Bitcoin. It has full support of that. External key management, so you can have the hardware key, or you can use the hardware wallet in the same way that you can use it in Bitcoin. So any wallet which is Bitcoin compatible, be it hardware wallet, software wallet, web wallet, any wallet which is Bitcoin compatible will also be multi-chain compatible. So consensus over data, not execution. So you cannot have the hard forks from this multi-chain network. No need to fees to stop runaway. So there is no any kind of a gas or any kind of a transaction fees associated. And the reason there is no fees is because since we cannot implement, now how do you create a private blockchain? So the first thing that you need is basically 2 machines. So I have taken these 2 VMs. Let's see if they are reachable with each other. So this particular machine has got IP address 172. This is the IP address. Let me see if I am able to ping this machine. 72.18.0. So these are pingable from each other. So therefore, I have taken these 2 virtual machines. They are both simple Ubuntu machines. Now let's see how do we create the multi-chain. So before even you can create the chain, you need to basically download and install the multi-chain network. So download and install. So these are the steps that you need to follow. Basically, to download the multi-chain instance, you first need to basically get this. So let me create a directory. Here also I will create demo1, space left on device. I will need to, so let's try to run it. So the first thing that you will need to do is you will need to basically get the multi-chain from this download link. So you just need to copy it and paste it. So you will need to do it on both the machines. And then what you will need to do is you will need to unzip it on both the machines. So what it will do is it will create these directories for you, like MultiChain 2.0.6. So I will do change directory this, and I will see these many applications installed. Here also I will go inside MultiChain.0.6, and these will be the scripts that I will find here. Now I will need to move these scripts to user local bin, so that I can actually use these scripts from anywhere or from any directory. I will move them to user local bin here also and here also. So it's all done. So now I am ready to create my multi-chain instance. So if I say getting started, so this is the command where I can create my new chain or a new network. So let's say I am creating it from this particular system. So I will name my chain as Educhain1. So this basically has created a new multi-chain network for me. I have not started the daemon, but I have created a new multi-chain network. These are the steps that you will find in the module also, like multi-chain create chain 1. We have created a new chain, Educhain1. So now what I will need to do is, now I will need to start this daemon. So what I will do is, I will write multi-chain D, the name of my chain Educhain1 minus DAEMON daemon, and I will run it in background, so that I can get my command prompt back. So till now what I have done is, I have just created a blockchain. Now I am starting the daemon of this blockchain. So here my blockchain is started. So now it is running fine. I will run it in background. So now it has started this multi-chain instance. So what it is doing is, it is telling that this instance has been started in a community edition, and if other nodes wants to connect, then they can connect it using this particular string 192.168.1.81, or this host has multiple IP address, so it can also connect it with 172.18.0.1, etc. Now if I want to connect this particular chain from here, I will give this command from this particular computer. So it is not allowing it to connect it. First of all, let me check the IP address again. 172.18.0. This is the IP address 172.18.0.1. We will need to use these addresses because these are different: 192.168.1.42, 192.168.1.81. So if I ping 192.168.1.42, this is working. And if I ping 192.168.1.81, this is also working. So let me see what we created. We created this instance. So we will need to give this particular command in order to run it. Now, as you can see that it has not connected successfully, but what it has said is that in order to connect, you will need to give this challenge string. So this is nothing but a public address of this particular instance. So in order to connect with this chain, what I will need to do is, I will need to grant access, and I can grant access from this admin node from where I have created this chain. I can grant access only for connect. I can also grant access for connect, send and receive. So as of now, I will grant access only for connect. So if I run this command here, so now this transaction has run successfully and I have given the permission to connect it. Now if I run the same command which I ran earlier, then it should be able to connect it now. So I am again giving the command to connect with this chain. Now it is not connecting because of the disk space issue. It should have been connected. So I have taken two other instances from my Google Cloud. So these two are again two Ubuntu VMs. We can test it on these rather than my earlier VMs. I think they were behaving a bit abruptly. So what we are trying to do is, we are first trying to create a blockchain daemon at one node, and that node by default will become the admin node. So that node will have an authority to basically create assets, to create streams, to give the rights to the miners. So that will become the admin node. The other node which wants to connect, they should know that what is the IP address and what is the port that I need to connect to the main chain. So the main chain admin will give them the connection string that they need to connect to. And once they attempt to connect to the admin node will throw a challenge string which the admin node will need to run before they can actually connect. So it's a two-way check that we need to do. Just by knowing the IP address, they cannot connect. So they will need to know the public key, which will be thrown as a challenge string before they can actually connect with the system. So what happens is, first of all, we will create a name of the chain. Say, for example, chain 1. In our case, we have created a chain, Edu chain 1. Now the second step is the params.dat. We will have a look. This will have all the parameters that we can configure for our this thing. Then we can create a daemon on the first machine using the multi-chain chain daemon. So what we have done is we have created this daemon here. So this is the command that we have used to basically create a or to run a or to start a daemon. We have appended ampersand at the end so that it runs in the background and I can get the command prompt back. So multi-chain D, which is multi-chain daemon, Edu chain 1 and ampersand. So it will run the daemon and it is saying node ready. And it will also give you the connection string that other peers can use to connect, which will have the IP address of this particular node as well as the port against which you need to connect with. Because each chain that you will create, you can have multi-chains also running in the system. So each chain will have a different port. So what it is saying is that, from other nodes, you can run this command to connect, but it is only giving you the IP address and the port number, which is not a sufficient characteristics to basically connect. So when other node try to run this command, when it runs this particular command, it gives you that, retrieving blockchain parameters from the seed node, blockchain successfully initialized. Please ask blockchain admin or users having the active permission to let you connect. It has given you this connection string. You need to run it from other node before you can this node can successfully connect. This will happen to all the nodes. So for example, if I have 10 nodes, so each node will receive a connection string and then I will need to run that connection string here. So it's a truly permissioned network where each node identify and know each other. It's like exchanging the public keys. So this in a way telling that, okay, this is my public key and you grant the connect permission to this public key. So when I run this command, grant this, and along with connect, I have also given the permission of send and receive on also. For just connecting, I need to give the connect permission. For sending or receiving any assets, then I need to give send or receive. So I have given connect, send and receive permissions. And this is the transaction ID that I have returned. This has run successfully. Now, after execution of this command, when I again start the daemon using the same string, then it has successfully executed. Now both my nodes are connected with each other on a multi-chain network. And you can see the amount of time it has taken to basically create this connection. It is very, very short. So now my chain is up and running. Two nodes are connected with each other. Similarly, I can have multiple nodes connected with the help of this admin node. We have already seen that either you can use only connect or you can use connect, send and receive. So we have used the second one so that we have given the connect permission, we have given the send permission, we have also given the receive permission. It is asking to give the connect permission, then the address here is unique for this particular blockchain. It will be different when you run your own blockchain. Now if you run the daemon, it will show as successfully started. So then if you want to see multiple parameters, then you can run multi-chain in an interactive manner using the CLI command. So you need to give this multi-chain CLI Edu chain 1. It will get into the interactive mode where you will not need to write multi-chain CLI every time. You can just give the commands and it will show you the entire thing. Here also you can give the same command, multi-chain CLI Edu chain 1. It will also go into the interactive mode. Now let's see what all commands we can do. So get info will give you the info about this blockchain. You can run it from either node. Both will show you the same information. So this is a community edition. The name of my blockchain is EduChain1. This is the description. The protocol which is used is multi-chain. These are the parameters that I have initially configured as a part of my initial block. So setup blocks, port number is 6821. If you remember, we gave this port while connecting. Okay. And these are the how many blocks can be created, what is the initial balance, what is the wallet version. These are some of the difficulty target, testnet, etc., etc. These are the values that we have initially given. The same thing will be displayed here as well if you run it from other node because we are using the same chain. Help will give you all the commands that you can execute from this console. So these are the set of commands. So it is a huge set of commands that you can use. Get block info, get block count, get difficulty, list permissions. All these commands you can use in MultiChain. Send, receive, publish, list streams, etc., etc. So if you want to see the list of all the commands that are available, so if I want to see what all permissions I have given to whom, then I can see it using list permissions. I have given connect permission, send this permission, receive permission to the other node, while I will also have the same permission. So list permissions. So these are the two basically entities. One is this one, which is myself. So this is the public address of myself, and this is the public key of the second node. So now let's see what permissions do I have. I have the permission of mining. I have the permission of admin. I have the permission of activating. I have the permission of connecting. I have the permission of sending. I have the permission of receive. I also have the permission of issuing the new currency, and I also have the permission of creating a stream. The other node is only having the permissions that I have given it, like connect, send, and receive. So it cannot create any asset. It cannot create any stream. It cannot mine the block. I have only given send, receive, and connect permissions to the other node. And this is the public key of the other node. If you remember, we gave the same key in the connection string also. Going back to the interactive mode, get new address, what it will do is it will give you another public address. So you can have multi-signature wallet, where you have multiple public addresses. So you can basically say get new address, it will give you the new address. Basically, this can be used along with the old address interchangeably. This is my original address, and then I have this new address as well. I can see both address by using the command get addresses. So get addresses, here it will show two address, and here it will show only one address. Get addresses. Let me copy it from here. Here it will show only one address. So this is my address, and these two are this node's address. To get the parameters of the blockchain, you can run get blockchain params. This is basically your params.dat file. So initially it was mentioned that your params.dat keep your configuration information, which is used in your first block or the genesis block. So these are the various information that you generally store: the name, the description, the root, what is the block creation time, what is the size of the block, what is the size of the chunk, what is the network port. Anyone can connect, false. Anyone cannot connect. In the params.dat, if you give it as true, then anyone can connect directly without using the challenge string. So by default it is false. Anyone can send, false. Anyone can receive, false. So you need to have explicit permissions in order to do that. Similarly, you have all the parameters. So here also you can see that same thing you can see in the other window as well. So it will show you the same parameters because they are part of the same chain. Get peer info is basically going to tell you that how many peers are there, and what are the characteristics of that peer. So this command will give you the different outputs in both the nodes because the peer information is different. Get peer info. Get peer info, here it is telling you this is my peer, this is the IP address, these are the services, and this is my local address, and this is my peer public address. Inbound is true, encrypted is false, starting height is this. Similarly, you can run it from other node. Get peer info. Here it will show that I am the current node and this is my peer node. So this is get peer info. If you have more than one peers, then it will show you the information for all the peers. Now, whether I have the permission to issue a asset or not. So let's come to the asset. So asset in this is basically anything that I defined with any kind of a denomination. So for example, I define a asset gold with the value 10,000. Then I can issue that asset to any other node, and I can give the permissions of using that asset to any other node. Now we are going to create a new asset and send it between nodes. On the first server, let's get the address that has the permission to create the address. So list permissions we have already used. It will give you all the permissions. Now, so which node has the permission to issue? Only I have the permission to issue the asset. only I am the one who can issue the new asset or create a new asset. So let's see how do I create a new asset. Let me try to issue the asset to this node. Let's say asset 1. So the meaning of 1000 is that this asset, total value of this asset is 1000, and I can divide it in 100 parts for each asset. It's like total 1000 rupees, and each rupee can have 100 paisa. So this is basically how much units you can divide it into. So I am creating a asset 1 with 1000 total assets and 0.01. So this is the asset that I have issued to the second node. Now let me try to list my assets. So this asset can be seen at both the nodes. I can see the same value here, like 100 total quantity is 1000. Each one is having 0.01 as a unit. Restriction send receive is currently false. I have only issued it. Same thing I can see here also. Sorry, which one was my first node? This is my first node. This is the asset that I have created. Now let's see the total balances. So here you can see that I have the balance of 1000, and here I don't have any balance because I have issued this asset to this particular node. So although it will show the asset at both the nodes, but the occupant of this asset is the second node, for where I have issued this asset. Now let's try to send this assets, say for example 100 units, to the first node. So what is the command? Send asset. What is the address of the first node? So this is the transaction which is done because I have already given the send and receive permission. Therefore, it has gone. If I only would have given the connect permission, then it would ask me to give the send receive permission here. The same thing, which I did earlier with the connect, I would need to do it here for sending and receiving the asset. So now if I see my total balances, it is reduced to 900. And if I see my total balances here, which was initially 0, it is 100. This is the simple way of transferring the asset from one node to another node. So you can create any asset with any denomination and any representation. So if you see that how you distribute the loyalty points specifically, then probably this can be easily used to that. Now after giving the permission, if you send it, then it will go through, and then you can check the balances again, 900 and 100. You can even see the transactions that are going to the blockchain. So because now we have done transferred some assets, so list wallet transactions. It will show you all the transactions that have happened so far. So for example, if I want to see the latest one, I will issue this. So this asset worth 100 has been issued from this address to this address. And this is the hash of the transaction. This is the index. This is the time of the block. So all those details with respect to this transaction are listed here. Similar things you can see here as well. This wallet transactions. It will give you the latest transaction. So it will say that minus 100 has happened. My asset has been reduced by 100 units. So now we saw that we can send asset. Now if you want to send some kind of a string also along with asset, that basically tells you that what this transaction was all about, then you can also send with data. So if I use the same command, send asset, send with data, the public key, and then you can mention any kind of a hexadecimal string which basically tells what this transaction is all about. Say for example 1 2 3 4. Then you have transferred 100 units of asset, but what you have also done is you have given a string associated with it, that what was the purpose of this transfer. So if I see get total balances here, now I have the balance of 800 because 100 units more have been deducted. And here if I see the balance, it will be 200. But the difference will be that if I view the latest transactions, if I see the transaction number 2, along with this 100, I will also see the data 1 2 3 4, the data that I transferred along with it. Similarly here also, if I see the latest transaction, I will also see the data along with the quantity of asset that is being transferred. So it's just like the earlier command. The only difference is I am also mentioning the purpose of this data transfer or any kind of a metadata associated with this transfer. This is all about, assets in multi-chain. Now the second thing that we can do is we can also create a stream. And then a stream means your basically a key pair value database that we can create, and then we can share that database from one node to another based on the permissions that we have created or that we have given. So create stream1 false. This has created a stream. Now let's see list permissions stream1. So these are the permissions for stream. So this particular address, which is my admin node, has created this stream1. This node can only use this stream as of now. All the rights, so be it write, be it activate, be it any other right, can be used by this node only. So I will need to give the right of using this stream to my second node. This is the permission. Now let's try to publish some data to this stream. So in order to publish the data, I will need to publish two things. So one is my key and another is my data. Data can be any data of your choice. So I created this stream on this node. Publish stream 1, key1, let's say 1, 2, 3, 4, 5, 6. So this data has been published. Now let's see if we are able to see this data across the second node. Now let's see the stream is visible on the other node or not. So here you will see that, okay, this is a root or this is a default. This is a default stream that you have. And then here is your stream 1. Now this is your stream 1. Now you have not subscribed to this particular stream. So the only thing that you can see is that there is a stream 1, but you cannot see the data associated with it. So you will need to subscribe to this stream. So again, there is a concept of permissioning here. So I have published this stream. So if I do list streams, I have already seen that, what is the output? List streams. Apart from root, there is a stream 1 also. I can see the same here also, but I cannot use or, basically see the data with this stream unless I specifically ask for the permission. I can see that the stream is created. This goes into the block as a transaction. Now, if the second server want to subscribe the stream, then it will need the permissions. So let's say it says subscribe stream 1. And then I am able to view the value that, okay, there is a key and there is a data as well. So now the second server has subscribed to this stream, so they can view the information. Now, for example, if they want to use this stream and publish any data to this stream, then they cannot publish it unless you give the explicit permission. So for example, if my second server say publish stream 1, say key 2, okay, any value say 7, 3, 3, 4, 6. Then third publish stream 1, and I publish only the using the same key. What you will need to do is you will need to give the permission of stream.write from the first node before the second node can actually write to this stream. So if you give this permission to the second node, then it can write to this stream and it can publish other keys and any value to this stream. This is the basic fundamentals of using the streams. Then you can see that what are my streams, how do I view key 1 related items, how do I view key 2 related items. So this is the basic fundamental. And then the last topic in this is mining. So by default, my first node is the miner node. So if I see list permissions, of mining, I am the only one who can mine the data. Now, if I want to give the permission of mining to the second node, then what I will do is grant the address of the second node. Now, this is my second node and mine. So now, if I see the mining permission, it will be to both the nodes. So my first node can also mine. My second node can also mine. Both will be mining in a round robin manner and will be publishing the blocks. So list permissions mine. If I will see, then both the nodes will be able to mine. Now I can set up the parameters of mining turnover 1, which will means that to maximize the degree of miner randomness, execute the following command. So this will randomly give the chance of each miner to mine the blocks. Then you can also see in the get info that how many blocks are generated and which miner has generated which block. So let's execute these two commands as well. So let's quickly run this at runtime parameter. So this is basically assigning the mining activity randomly. If I see get info, I will come to know that how many blocks are created. So currently, with all the operations that we have done, 124 blocks are already created. Now let's see that, get block 124, which is our last block. Now here I can see the miner. This is my which node? This is my first node is my miner. So now if I see some other, say for example, if the new blocks are created in the meantime, so currently blocks are 124. Maybe if new blocks are created, I can see this node also creating the blocks. So I can designate the miners. I can see the random behavior of mining activity as well. So this basically completes your multi-chain. So by now, I think must have understood what are the practical applications of blockchain, or which industries are basically going to completely change or disrupt using the blockchain technology. And the same analysis has been done by multiple research organizations such as Gartner. Harvard has done some research, and there are many research papers around what blockchain's potential is and what it can do in the future. So some of the industries that are completely going to get disrupted by blockchain technology, it starts from the financial application. So the financial applications is something that you can immediately relate blockchain with, starting with cryptocurrencies. And cryptocurrencies are getting more and more popular now, seeing the failures of conventional fiat currencies and the tools associated with them. So we have seen the banks getting failed in the recent times. We have seen that the mutual funds getting shut down. So we have seen that any kinds of bonds or derivatives or shares that you can buy from the markets are not performing well, but cryptocurrencies continues to do well even in this tough time. So cryptocurrencies or digital currencies are getting themselves established in the market as one of the major player of how the future currencies will be represented. I think more than 30% of the total world's wealth or the GDP will be on blockchain technology by 2030. And by 2024, at least 10% of the world's GDP will be on blockchain. And that will be only through the financial applications. So for example, you might have heard recently China announcing that it is going full-fledged into a blockchain-based digital currency. You might have seen that Dubai is completely moving into the blockchain as a blockchain smart city. Estonia is one country where they have already started using the cryptocurrency as their main currency. They have their own cryptocurrency and they have the crypto ATMs as well. One of the main advantages or is that these digital currencies do not have any kind of a barriers with respect to the cross-border payments. It becomes very easy for cross-border payments to happen using the cryptocurrencies or the digital currencies. One of the practical application, if you want to see, is a solution called WorldWire. So this is the solution by IBM, which is used for cross-border payment using the IBM blockchain. And this is basically developed in using Ripple. Ripple is another blockchain stack for financial applications, and IBM has created this WorldWire solution where you can transfer the payments from one country to another country within few seconds, which currently takes days if not weeks. Due to the various regulatory bodies, due to the various kind of intermediaries, you end up paying 20 to 25% commission. And by using this blockchain solution, and most of the banks are currently moving to this solution. So you will not even realize that in the future, maybe few months or few years from now, you will start seeing that the cross-border payments are being settled in within seconds as your in-country payments are getting settled now. And basically all your governance, everything will be done by the WorldWire. Thank you very much.